This is the second video on the DC power monitoring module. At this video, I will show you how you can communicate with the module over I2C using any microcontroller. First, go to the product page on our website and scroll down. Open the I2C driver C library. This will take you to a public repository. You can either clone this repository or download it manually. When you download it, it will be downloaded as a zip file. You can open it and then attach it to your project. So this is the downloaded file. It has a header file and a C file. Then you can open your preferred microcontroller C project and add the libraries. I am using an ESP32 microcontroller, but it doesn't make a difference which microcontroller you use. The steps are pretty much the same. So first, let's look at the hardware wiring of the module. So on wiring, it looks something like this. You need to power up the D-Power module with your microcontroller. So I have two jumper wires. The red one is connected to my ESP32 3.3 volt and the black wire to ground. And then I need to connect the serial clock and data line for my I2C on the D-Power board to my microcontroller I2C pins. And in my case, the clock line is on pin 22 and the data line is on 21. Now let's head to my ESP32 project and I'll show you how you can code this one. So here is my blank ESP32 project. I created this empty project and I added my essential I2C includes, my delay function, get ticks, and I also initialize my I2C line. So you can see my I2C pins are 22 for clock and 21 for data. The clock speed is 100 kilohertz and it's on master mode. So this would initialize I2C and get it running. And I have this infinite while loop on the main, currently just printing hello world. I also added the I2C driver to my project. So I added a component called D-Power and I added the MPI2C header and the MPI2C source file. Okay. Now let's begin and I'll show you how you can use this library with the ESP32 microcontroller. So first, let me include the library. So it's the MPI2C and my main file recognizes that. The first thing we need to call is our MPI2C initialize function to initialize this library. The initialization function takes on an initialization structure. We will call this one MPI2C init and we will initialize it to 0. Now we will fill in this initialization structure. This takes 5 parameters. It takes a pointer to the delay function, a pointer to the get millis function, and a callback to I2C read and write and the I2C address. Let's begin with the I2C address. My default I2C address is 8. Now let's pass the delay function. I've already created one. This is a millisecond delay. So if you're using an STM32 microcontroller, you'll need to pass the HAL delay. So this is the delay function of your microcontroller. Now similarly, the third parameter is the millis. So to get the millisecond counter, I have a function for that. Now again, this would depend on your microcontroller that you are using. Now the last two parameters are the I2C read and write callbacks. The I2C read and write callbacks have the following format. So you can open the driver header file and you can see the format for our write and read callback. So they have three parameters and they return a boolean. Let's just copy all of them. I'm going to create the function prototype at the top. So this returns a boolean and I'll call it d power I2C write, and it takes those parameters, the slave address, the write buffer, and the size. The same thing for the read function. So it's d power I2C read, and it takes those parameters. Now you don't really have to have exact naming. You can name them differently in your main, but I can also copy and paste them with the names, with exact names. Okay, so those are the function prototypes for our library write and read callback. Now let's do the function definitions. So those are the function definitions for the library I2C read and write callbacks. Now in here, you need to call your MCU I2C write function. And here, you need to call your MCU I2C read function. So that's what links the library to your microcontroller. Now let's pass those pointers and we'll come back in a minute and then code the MCU I2C write functions for our ESP32 microcontroller. So here we pass the write callback, and now we'll pass the I2C read callback function. So these are the callback functions with the formats that the library expects. Now we will link them to our ESP32 I2C read and write. Okay, so now we filled in this MBI2C initialization structure. Now we need to pass it to the init function as a pointer. And this takes a second parameter. It takes an empty MBI2C handle pointer. So we will define the MB handle in our main file at the top. This is a global. We will call it MBI2C handle, and we will initialize it to zeros. It's a very good practice to initialize handles before you use them. Now we pass it to this function as a pointer. Now this one should initialize our MBI2C library, and then it's ready to be used. Now let's code the I2C write and read callbacks. Now those would depend on our ESP32 I2C, and on ESP32 I2C library, if you navigate to the I2C header file, there are two functions of interest. There is this function, write to device, and it takes the port, the address, the write buffer, the size, and the timeout. And that's pretty much what we need to use in our write callback. So let's call it in the write callback. Now the port in the initialization, it's I2C port 0. We have a define, so we can reuse it in here. The second parameter is the address, and it's the parameter of the callback. The third parameter is the write buffer, and again, it's passed by the library as a parameter to the callback, the size, and finally, the timeout. And we want to convert the milliseconds to ticks because this function expects a ticks format. So 100 milliseconds is a good timeout for I2C, although it should be much faster. Okay, now this function returns an ESP error status. We call it ESP status. and we will check if the status is okay, then we are good to go. We will define a normal status, initialize it to false. Now if the ESP status is equal to OK, we will set our Boolean status to true, and we will return it at the end of the function. Now, very similar thing to the read function. So we're going to copy everything over, and we will replace the write to device with read from device. Now the read from device takes pretty much similar parameters except the buffer. Instead of write buffer, now it's the read buffer. Okay, so that is our write and read callbacks. We integrated the library read and write to the microcontroller read and write. Now let's test this library. Now we initialized it. Let's call one function just to make sure the library is working and it's connecting to the device successfully over I2C. Now we can look at the device user manual from the website. So if you go to the product page, you can look at the user manual, and you can scroll down to the registers map. Maybe let's try to read the default slave address register. So this one is a holding register with address 0, and the type is unsigned 16. If you look at our I2C driver for the dpower module, it has write holding, read holding, and read input generic functions, and it has formatted read and write functions. So if we want to read an unsigned 16 register, we don't have to use the generic read, we can use the formatted read function. So let's use this one to read the default slave address. So this one takes on the MBI2C handle pointer and the register address, so that's register 0, and then the data pointer, so it can write to that pointer. So that will be our default slave address. And then the register type. If you look into the header file, the register type enum is either, if you are reading unsigned 16, you're either reading a holding register or an input register. At this case, we are reading a holding register, so we set the register type to holding. Now this function returns a Boolean status, so let's assign that to a variable. We'll call it MB status. Now we will check if MB status is true, or actually we can just log the status directly. So we can write to the log that we are reading the slave address. And the status of the read. So the slave address is the value read, and the Boolean status. Okay, so let's build the project. I have my microcontroller connected to the dpower module, and they are powered up and connected to PC. And it's on COM5, so let me flash the board. And we will take a look at the terminal. If the slave address is read successfully, the default value is 8, and the status should be 1 for successful. So let's open the printf terminal. And here we go. The slave address is 8 and the status is 1. So here we go. We connected the dpower I2C library successfully to an ESP32 microcontroller, and we can read the slave address correctly. Now let's read a bunch of registers, maybe the voltage, current, power, and energy registers. So let's read those. I already have the code ready, so let me just copy it over. Okay, so here is the code for reading an input register. This is address 42 for the real-time clock seconds. The address 80 is channel 1 voltage, 82 is channel 1 current, 84 is power, and so on and so forth. So those are the power data registers. So let's build the project and flash it. And we expect that we read those from the device. I'm going to power up my power supply that I use for my test load. The voltage supply is 24 volt, and I expect about less than quarter an amps. Okay, now the power supply is turned off, but I can see all the status are 1, so I'm reading the seconds successfully, the voltage, the current, the power, and the day energy, and also one of the holding registers for data log enable. I'll put my power supply on, and I can see the voltage change to about 24 volt. The current consumption is 0.18, the power consumption, and the day energy. So that's all I want to show you. That's how to connect our D-Power module over I2C to an ESP32 microcontroller at this case, and pretty much to any other microcontroller. Thank you.